Our bodies emit a multitude of signals that can be measured from outside using wearable devices. These biosignals, which encompass everything from heart rate to sleep patterns and blood oxygen levels, provide valuable insights into our physical and mental states. By deciphering these signals, researchers and medical professionals can identify potential health issues before they become severe, making it possible to diagnose diseases and disorders more effectively. However, the process of analyzing biosignals is not without its challenges. Firstly, gathering a substantial amount of data is relatively inexpensive, but teaching a machine learning algorithm to recognize patterns in this data is a different story altogether. This is where computer engineers like myself come in. We're responsible for developing algorithms that can learn from large datasets and identify relationships between biosignals and health disorders. One of the most significant challenges we face is the labeling process, which requires experts in various fields to review millions of data points and assign labels to instances of a specific disorder. This process is not only time-consuming but also expensive, with the cost of labeling increasing exponentially as the complexity of the disorder increases. To overcome this hurdle, researchers have been exploring innovative methods to train machine learning algorithms with fewer labels. One such approach is called pre-training, which involves teaching the algorithm to recognize patterns in large, unlabeled datasets before applying it to the specific disorder in question. Pre-training allows the machine learning algorithm to learn the underlying relationships between biosignals and disorders, enabling it to recognize patterns that may not be immediately apparent from the data. This is particularly useful for disorders like atrial fibrillation, which can be difficult to diagnose due to the presence of noise and variability in biosignals. Challenges of working with biosignals. Noise in biosignals. Biosignals can be affected by various external factors, such as the movement of wearable devices or the location of sensors. Inter-individual variability. Every person's biosignals are unique, making it challenging to develop algorithms that can accurately diagnose disorders across different populations. Complexity of relationships. The relationship between biosignals and disorders can be complex, making it difficult to identify patterns and make accurate predictions. Learning to fill in the blanks. One of the most promising approaches to addressing these challenges is to pre-train machine learning algorithms on large, unlabeled datasets. By doing so, we can teach the algorithm to recognize patterns in biosignals and fill in the gaps, making it easier to identify disorders. In our research, we've developed a method to pre-train machine learning algorithms by creating artificial gaps in biosignal data and asking the algorithm to fill them in. This process, called filling in the blanks, enables the algorithm to learn the underlying relationships between biosignals and disorders. By pre-training the algorithm to recognize patterns in one biosignal, we can then apply it to other biosignals with fewer labels. This approach has shown promising results in our research, demonstrating the potential for faster and more efficient disease detection. Faster disorder detection. Development method. Advantages. Disadvantages. Pre-training reduces cost and time spent by experts. Labeling requires large, unlabeled datasets and complex algorithms. Using unlabeled data as a warm-up can improve accuracy and efficiency of disease detection. May require significant computational resources. By leveraging pre-training, researchers can accelerate the development of machine learning algorithms for disease detection, leading to faster and more accurate diagnoses. This has significant implications for the early detection and treatment of diseases, as it enables healthcare professionals to identify potential health issues before they become severe. Moreover, the use of pre-training can help reduce the cost and time spent by experts labeling, making it a more efficient and cost-effective approach to disease detection. As researchers continue to explore the potential of pre-training, we can expect to see significant advancements in the field of biosignal analysis and disease detection. Conclusion. In conclusion, the field of biosignal analysis has made significant progress in recent years, and the use of pre-training has emerged as a promising approach to accelerating disease detection. By leveraging pre-training, researchers can develop machine learning algorithms that can accurately diagnose disorders and identify patterns in biosignals, leading to faster and more accurate diagnoses. As we continue to explore the potential of pre-training, we can expect to see significant advancements in the field of biosignal analysis and disease detection. With the increasing availability of wearable devices and the growing amount of biosignal data, the potential for pre-training to revolutionize disease detection is vast. Ultimately, the use of pre-training has the potential to transform the way we approach disease detection, enabling healthcare professionals to identify potential health issues before they become severe.